Let's take very simple problem. So a concrete column is reinforced with 4 bars of 20 millimeter diameter. So basically we have a concrete column which is reinforced with 20 mm diameter bars, and we have 4 number of 20 mm diameter bars. Determine the ultimate load carrying capacity of the column using M20 grade concrete and Fe415 grade steel. So basically we have to find out what is the maximum load carrying capacity of this column. Okay. And the grade of concrete is M20 and Fe415 grade steel is used. If the size of the column is also directly given to you, this is an analysis type problem. So the size of the column is 450 millimeter by 450 millimeter. What will be the allowable service load? So basically in this case we have a column like this. Say the dimension is 450 by 450. And we have 4 number of bars provided in this, and these 4 bars are having a diameter of 20 millimeters, and we are using M20 grade concrete and Fe415 grade steel. So our question is, what is the load carrying capacity of this column? So as an engineer, I have already told you, you might be getting for proof checking, or sometimes there may be some dispute between two parties, and as an engineer you have to actually work out and check whether the columns, the provided cross sections are enough for carrying the expected load. For that, what you have to do, you have to actually, based on the given cross section, you have to calculate what is the load carrying capacity of that section. So such a problem is here. So basically we have a column like this. So let's see how to do it. So the column size is 450 by 450, and as I already told, as per clause number 25.4, instead of calculating the unsupported length by 500 plus least lateral dimension by 30, we are directly taking the minimum eccentricity to be 20, because this is the minimum possible value of eccentricity. Okay, so we are just assuming that the minimum eccentricity is 20 millimeters. Now what we have to do is that we have to ensure that it is an axially loaded column. So what we will do is that we will calculate the value of 0.05 times the lateral dimension. That is, in this case it is a square column, so 450, 0.05 times 450, that is coming around 22.5. So basically this is a larger value than the minimum eccentricity. So our condition is actually satisfied. So we have this clause satisfied. So now what we can do is that we can utilize the formula for calculating the load carrying capacity. Now what we have to do is that we right now have the cross section of the concrete as well as the area of steel. So the total cross section, or the gross cross section, is given by 450 into 450, which is coming around this much value, and the AS, or the area of steel, is given by pi by 4 into d square into number of bars. We have 4 number of 20 mm bars, so accordingly we will be getting the area of steel here. Now what we have to do is that we have to find out the area of concrete alone. Okay, so you know that in columns, as we have already drawn the cross section, in this cross section, A gross means it is the total area. This is 450 by 450, so that is what is we calculated as AG. From this we have to actually separate the area of this 4 reinforcement, so that we will get the value of area of concrete alone. So please note this, we have to calculate the value of area of concrete alone. So what we are doing is area of concrete is equal to total area minus area of steel, and that is coming around this much value. Now we can directly substitute in this equation, that is the total factored load that can be carried is 0.4 times FCK into area of concrete plus 0.67 times Fi into area of steel. We know the value of area of concrete as well as area of steel. Substitute that and it will be coming around 1959.4 kilonewtons. But please note, this is the design load that can be carried by the column. And in the question, it is clearly asked that we have to find out the allowable service load. So how to find that? Basically, design load will be obtained by multiplying the service load by the factor of safety. In our case, factor of safety is 1.5. So in order to calculate the service load, what we have to do is that we have to divide the design load by the factor of safety. That is what is done here. So finally, we will be getting it as 1306.2 kilonewton. So basically, the load carrying capacity or the service load that should be provided on this column is 1306 306.2 kilonewtons. Okay, is there any doubts in this? Is it clear?
Yes,
Clear,
sir.
sir.
It's clear, right? So this is how we will work out the load carrying capacity of a column. So I will give you time for doing this problem. So let's take one more problem. So basically, design. This is a design type problem. Design a short axially loaded column of size 500 by 500 millimeters for a service load of 2000 kilonewtons. Use M20 grade concrete and Fe14 grade steel. So the cross section is given to you, but the steel that should be provided is not mentioned. Instead, they have mentioned that we have to actually use this column to carry a service load of 2000 kilonewton. It is a service load that should be carried is 2000 kilonewton, and the grade of concrete and steel is given. Now let's see how to find out the area of steel. So this is the cross section. Then again, we are assuming the minimum eccentricity to be 20, and we are checking this 0.05d is greater than 20. We are getting it as 25, so it is greater than 20. So we can use this equation, and the gross cross sectional area is this much. Again, the concrete area of concrete will be the difference of gross area and the area of steel. So we are just substituting that, but we don't know the value of area of steel. So we are keeping it as the variable itself. And again, the factored load is, we were given a service load of 2000, so the factored load or the design load is 2000 into 1.5, that is coming around 3000 kilonewton. Now we are just substituting these values in our equation. That is, this is design load, that is 3000 is equal to 0.4 FCK into AC. We don't know the value of AC, so we will substitute it as this value minus area of steel plus 0.67 Fy into area of steel. Okay, so we have just reduced the number of unknowns to 1. So from this you can find the value of AS. Direct substitution, there is nothing else. You will be, for your examination, you will be getting these type of simple problems from short columns. So earlier I have already told you that we will be able to save a lot of time if you are fastly doing the problem from columns, from this module. Basically, you will be getting a question from columns and one more question from staircase. This is optional. So normally if you are attempting this, it will be easier for you. You will be able to save a lot of time. But coming to helical reinforcement, there is slight confusion. But anyway, in that case also we can save a lot of time. So we will see that. Is this problem clear to you? Any doubts in this? Very simple, right?
It's clear, sir.
Yes, sir.
Okay, so we will discuss one more. So basically, once you get the AS, what you have to do is that you have to actually find out number of bars required. So basically, this is the total area. So we will assume that we will provide 20 mm diameter bars, and in this case, we are getting it as 11.79 number. So we have to provide at least 12 number of 20 mm diameter bars, but that is too much for a column having a dimension of this much. So what we will do is that we will try with a higher diameter so that we can reduce the number of bars. So what here they have done is they have taken 25 mm diameter bars. So again they are checking how many number of bars is required. So total area of steel required divided by area of a single 25 millimeter bar, and that will give us 7.54, so that we have to provide at least 8 number of 25 millimeter bars. So the actual area provided is 3927 millimeter square. Now what we have to do, we have right now provided the longitudinal reinforcement. Now we have to provide the ties also. So what we are doing is that we are using 6 mm dia ties, and the spacing required is the least of, we have already seen that we have 3 conditions: least lateral dimension, 16 times the smallest diameter of the bar provided. But here we have uniformly provided 25 mm bars. So 16 times 25 and 300. We have to actually take the least of this. Okay, so from these 3 conditions, we will get 300 millimeter as the least lateral dimension, So we have to actually provide the center to center distance between the ties as 300 millimeters, and finally you have to provide a detailing like this. A better practice is to avoid providing ties like this. Say if you see this, they have actually provided one tie here around these bars and another tie like this in the diamond shape. Okay, and that too at the same location. At this location itself, they have provided both this configuration. Normally in the field, it will be very difficult to tie things like this. So what we usually prefer is that, say suppose you are getting this center to center distance as 280 millimeters. So what we will do is that we will provide this rectangular one at 280 millimeters center to center. Okay. Then what we will do is that at the exact center of this, that is at 140 distance, at 140 distance, we will provide this diamond shaped ties like this. We will tie these bars so that it will be easy for creating these cages and casting the column. So that is a practice based on the practical experience. We usually do it like that. So please keep that in mind. And the main thing that you should note is that you have to ensure this spacing that you have already calculated in between two ties, and at the exact center of this you have to actually provide this diamond shaped ties. Okay, now we will take up this problem. I hope you are able to see the presentation. So basically this is a pure design problem. We have to design a short axially loaded circular column to carry a service load of 1000 kilonewton. Please note it is service load of 1000 kilonewton. We are supposed to use M20 grade concrete and Fe 415 grade steel. So let's see how to do that. And if you remember, what is the minimum percentage of steel that we should provide in the case of column, and what is the maximum percentage of steel? Can anyone tell me? No idea. Okay, so it was 0.8 and
6%.
yeah. Okay, fine. So that's it. That is the upper limit and the lower limit. So please keep that in mind. Anyway. So let us assume that D is the diameter and minimum eccentricity is 20. And I have already explained how we got this 20 value. That is from one of the clause given in your code itself. Rather than going with that equations, we are taking the minimum requirement, 20 mm. And we are just, for this design problem, we are just assuming that our column is an axially loaded column. So for a column to be axially loaded, what is the condition? This condition should be satisfied. That is 0.05 D should be greater than the minimum eccentricity. We can provide only 5% allowance. As I have shown through a picture, we can provide 5% allowance, so that 0.05 D should be greater than 20 mm. If that condition is satisfied, it can be taken as a axially loaded column. So we are just directly assuming that it is an axially loaded column. So this condition should be satisfied, so that we can use this equation for our calculation. That is our target. Okay, and we are assuming that the total cross-sectional area is AG, and the percentage of reinforcement provided in is a value in between 0.8 and the higher limit. Okay, so in this case they have taken it as 1%. These things are randomly taken. They are taking it as 1%. Now what they are doing is that our equation was PU was equal to 0.4 times FCK into area of concrete. So please note it is area of concrete. So in order to get that, what we are doing, from the total area, that is gross area, we are subtracting 0.1 times area of gross. Why we are doing that? Because the percentage of steel provided, we are assuming that the percentage of steel present in my gross area is 1%. That means 0.01 times the total gross area, which is 0.01 Ag. So in order to get the area of concrete, I have to subtract 0.01 Ag from the total gross area, so that I will get AC. As per equation, we have to substitute AC here. So I have just substituted and found out the value of AC in terms of Ag, gross area. Okay, plus sorry, 0.67 Fy into area of steel. Area of steel here is 0.01 times Ag. Okay, so I am directly substituting that here. So this is I have just converted this equation in terms of gross area, and from this what will be PU? PU will be 1000 is our service load, so we have to factor that 1000 into 1.5. So that will give me 1500 kilonewton. So when I substitute it here, it will be 1500 into 10 raised to 3 newtons. 1500 into 10 raised to 3 newtons. Please take care of the units. Generally, students will commit mistakes here. They will just substitute it as kilonewton and they will substitute FCK in Newton per mm square. That will make the answer completely wrong. Okay, so please take care of that. So here we have to substitute 1500 into 10 power 3 is equal to 0.4 FCK into Ag minus 0.01 Ag plus 0.67 Fy into 0.01 Ag. So if you look into this, the only unknown quantity is gross area. So from this you can simplify and find out the value of Ag. So in this particular case, we will be getting Ag as 140180 millimeter square. Okay, so this is the required area to carry safely carry a load of 1500 into 10 raised to 3 newtons. Okay. Now, in the question, it is clearly mentioned that we need a circular column. So, what do you have to do? You have to find a diameter so that the net area will be 140180. So, pi by 4 into d square is equal to this value. From that, you can find out the value of diameter. And in this particular case, you will be getting the diameter as 422.5 millimeters. So, this is sufficient to produce this much area. Okay, but in practical point of view, we cannot again provide a diameter like 422.5. So we will be rounding it up. This is diameter, so we will be rounding it up to a value of 425 millimeters. Okay, so 425. Therefore, therefore the area of steel is equal to how much? It will be 0.01 into 140180. Why I haven't again calculated the area using the reversed diameter and substituted here? I have just directly taken the just required area for the calculation of steel. Here we have provided more area than required, but while calculating steel, I have just taken reference to the area which is just sufficient. Why I have done that? Anyway, in the last class it was full of confusions. So last class we have already discussed that as per code, there is one clause where we have discussed that whenever the area provided in the column is larger than that required, and in such case, when we calculate steel, that calculation should be done with reference to the necessary area, that is the area just required to carry the load. We have a clause. Yesterday we have actually discussed about that clause. If required, after this class, you just go through the clauses which we have yesterday discussed. So there we have one clause. That is the reason why area of steel is calculated in terms of the area which is required to carry 1500 into 10 raised to 3 Newton. Okay, so from that we will get it as 1401.8 millimeter squares. So now we will calculate. I am assuming that I am going to provide 16 millimeter diameter bar. So how many bars are required? So this area divided by area of one bar, that is coming around 6.97. So let's provide. It is anyway a circular column, so let's provide 7 bars. Okay, equally distributed. And again, we have different conditions for providing the bars. So in the case of circular bars, the peripheral spacing between these bars should be equal. It should be equally distributed. Okay, so 7 bars should be equally distributed inside this circular column. Okay, so we will provide 7 bars of 16 mm diameter. Now, what I am doing is that the minimum diameter specified for stirrups is, not stirrups, the ties is 6 mm. So I am directly taking it as 6 mm. So using 6 mm diameter bars for ties, the minimum spacing between the ties is, we have discussed now, we have 3 conditions. First one is least lateral dimension. Since this is a circular column, least lateral dimension will be 425 millimeter. Then 16 times the largest diameter of the longitudinal bar. 16 times, here we have uniformly provided the diameter as 16 millimeters. So 16 times 16, which is coming around 256. And the third condition is 300 millimeters. And we have to take the smallest value in this. If you see, the smallest value is 256. Again, to provide ties at a distance of 256, it is difficult, practically not possible. So what we are doing, this is center to center spacing, so we will round it down. So we are just rounding it down to 250 millimeters center to center. So hence you have to write, hence provide 6 millimeter diameter ties at 250 millimeter center to center. Is your problem complete now? No, you have to draw the detailing also. Okay, so once you draw the detailing only, this will be complete. So basically what you have to draw, you have to show the cross section, then you have to show 7 bars equally distributed, then you have to show the tie which is provided around this longitudinal bars. Then in this cross section you have to show this, how much phi at what spacing center to center. Then you have to show how many number of these bars, 7 nose of 16 millimeter 5 bars. Okay, 5. So again to the bottom of this, in line with this, what you have to do? You have to draw the sidewise cross section also. So then only we will understand whether it is a helical reinforcement or just a what rings. Okay. So you have to show the cutting continuation. Then you show the main reinforcements. Based on this figure, you just draw all the required reinforcement. Then you show the ties. Here we have just provided rings. So then what you have to do? You have to show like this. Ties. This is at actually 6 millimeter 5 at 250 millimeter C by C. Then we have these reinforcements. So 7 nose of 16 millimeter 5. Then you have to show the diameter. Anything else? You want, you can show the cover also. So these things must be given, then only it will complete your problem.